Good morning, class. Happy Tuesday. I hope you enjoyed yesterday's lesson about displacement. That was a lot of fun. And today we're basically going to be applying this a little bit more directly and doing some math, of course, to do with it. So we remember that when an object is submerged in water, it displaces a volume of water that is equal to its own volume. Okay, and we also see that the water will rise to a new height. Okay. We can use this change in height to find the volume of the object. And so that's the key thing that we're going to be doing today. We saw yesterday that the height changed when we put stuff in. And so now we're going to be looking at it in a sense that is not these nice measured cylinders, but we're going to be looking at boxes, okay? And I want to remind you that we know that a liter equals 1,000 centimeters cubed, which is the same as 1 centimeter cubed being 1 milliliter. Okay, so just hang on to that information too, because that's going to help us today as well. So we're going to be looking at displacement, and we're starting on page 84 in our textbook. So if you need to, take a minute and grab that, and we're going to work on these two questions to determine the volume of different unknown objects. Okay, we're going to see what these questions ask of us. So number 1 says a regular tank 30 centimeters long and 20 centimeters wide is filled with water to a depth of 8 centimeters. When a stone was put in, the water level rose to 11 centimeters. Find the volume of the stone. Okay, so we see our two boxes. So there's the empty box with just water in it, and then there's what happens when the stone is added. Okay, and the question guides us to see that the water rose by 3 centimeters. Okay, so the increase in the height of the water level equals the new height minus the original height, which equals 3 centimeters. Okay, and we can see that there, right? So this one is 8 centimeters high, and this one is 11 centimeters high. Okay, so in order to find the volume of the water that was displaced, we need to use our volume formula, okay, which is length times width times height. So we're doing 30 times 20 times 3, okay? And it's just the water that's displaced, right? So it's the 3 centimeters that the height rose with the stone coming into the water, okay? And so 30 times 20 is 600, and 600 times 3 is 1,800. Okay? So that means that the volume of the stone is this value, right? Because we know that the volume that's displaced is equal to the volume of the thing doing the displacing. Okay, we see that here. That's our rule that we wrote down about displacement. Okay, so this number is the displaced amount of water, but that also means that it's the stone. Okay, so the stone is 1,800 centimeters cubed, or we know that that means it's 1.8 liters. Okay, so now we're going to look at it the other way. So what if something is taken out of water? Okay, and the height's going to go down. What do? Let's see. So question number 2 says that a rectangular tank 30 centimeters long and 18 centimeters wide contains some water and a stone. So the water starts with a stone. Okay, when the stone was taken out, the water level dropped by 2 centimeters. So find the volume of the stone. Okay, so they help us out by making it pretty straightforward and telling us what the difference in the height is. So the height decreases by 2 centimeters. So that means that that's the height that we're going to plug into our equation, because that's the height that has been displaced. Okay, so let's plug that in. We have 30 times 18 times 2. Okay, because the 2 is the height that was displaced. And 18 times 2 is 36. And 36 times 30 is 1,080. Okay, so our answer is 1,080 centimeters cubed. Okay, and so that's the volume of water that's displaced. So that means that that is the volume of the stone. Okay, so that is it for the lesson today. So when you're looking in your workbook on exercise 55, please keep this in mind that we're using the height that was displaced, okay? So in this case, there was 3 centimeters that was displaced, right? Because it went from 8 to 11. And in this case, the question just tells us that it was 2 centimeters that's displaced. And the reason that we're plugging the displaced height into our equation is because it is equal to the volume of whatever object displaced it, okay? So that is your lesson for today, and your task is exercise 55. And if you have any questions, please feel free to reach out to me, and I'm also going to be in the Zoom on Thursday, so I can see you then as well. All right? But that is math for today.